All right. Hi, teams. We are Team 10-4-6 the Bionic Tigers, and we're going to be going over build and robot controls. This meeting will be recorded and most likely posted on YouTube later after this meeting. So if you want to go look back at that, you can definitely do that on our YouTube page. I'm Justin. I'm the build lead on our team.
I'm Jake. I'm a build member on our team.
I'm Sarah. I'm a build member on our team.
I'm Leah. I'm a member.
Oh, you had, sorry.
Go. Oh, I'm Leah. I'm a member of the build team.
I'm Grant. I'm also a member of the build team.
I am Jamie. I'm the programming lead for this team.
I'm Alex. I'm a member of the programming team.
All right, so first we want to have a little introduction of who we are as a team. This is our 9th year and we're made up of 12 members. So a few history facts that our team has gone through is that we have won the Inspire Award at Kentucky Championship in 2021 and 22. And that same year, we also won the Think Award and Freight Frenzy at Ohio State that time. And we also placed first, we won the Inspire the first in the first Ohio qualifier that year too. We have won almost every award that's possible to win in FTC. We have qualified 3 years consecutive for Worlds, and we have been named Ohio Showcase Team in 7 years in a row. All right, so the purpose of this workshop is going to be helping you learn and experience what we have learned about the robot and give you a few tips of how we do what we do and what works and what doesn't work for us. And so this is going to be a build and robot control basics, which is going to be basic build stuff you can learn and basic programming too. And then we have two other outreach events coming up. It's the third one next Wednesday is going to be FTC outreach. And I believe the 2 Wednesdays after that's going to be FTC and Kotlin and Java. All right, so we're going to go over what's covered today, and that's going to be our design process as a team, drive types and drive methods, mechanisms of how you're scoring points on the field, wiring, build tips and tricks, drive system hardware, and understanding hardware. So all these are needed to be successful with your robot and scoring points on the field, and almost all of these will be needed in some sort of way on the eventually for your team. All right, so the first we're going to go over the design process.
All right, so this is a very basic overview of our design process, and we will go into more detail on these steps later, but I'll just read it in order. So first, what we're going to do is we're going to read and understand the game manual. Next, using the knowledge that we gained from reading and understanding the game manual, we're going to brainstorm. Then after that, we're going to research, prototype, and test. Then we're going to select a final design and mechanism. And then we're going to test the mechanism thoroughly and iterate as needed.
So our first steps is, of course, reading the game manual and discussing with your team. So during this, you want to have an open. So what we do is we have an open brainstorming session with our entire team and try to figure out what ideas are possible that we could do. And these can be as extreme as possible, and they can even include illegal ones. However, after that initial brainstorming session, you want to do two types of iteration where you want to eliminate the illegal ones, and then you want to combine the possible ones together to create the next opportunity. You don't want to really eliminate the crazy ideas because those are often the ones that might be the most successful out of all of them. And then you want to figure out which ideas you want to pursue in the future. It's possible to have 5 to 6 different mechanisms or even more. And if it's not really feasible to make all 5 or 6 mechanisms, so you want to be choosing 2 or 3 that you think are going to work best. And maybe that are going to be a little bit of a long shot, and then move from there. So after selecting each of these mechanisms, you want to prototype these to compare to each other. And there's plenty of resources of what mechanisms you can look at, and including the YouTube and forums. And there's plenty of help also on there to learning how to make these.
The next step will to be prototype your mechanism that you have chosen to test. And so a prototype is a proof of concept and should function at least relatively similarly to what your final mechanism will. So, and they should be changed rapidly. And you always want to compare multiple prototypes at once, as having multiple iterations of a prototype going for different prototypes, you'll be able to more easily understand what you want and what will work and what won't work. It's always really important to have a consistent design, as even if your design is good and it works really well a few times, if it's not working well very consistently, it's not going to do well overall. After you have your prototypes made and understood, you're going to want to start designing and building your robot. So once you have your prototype finished, you're going to turn that into your true mechanism that you're going to be using on your robot. And that will take a lot of time and iteration, but once you have a final design, you're going to want to model it in CAD software, or at least make a dimension drawing on using something. CAD is a very good tool that we use, and it allows us to get an idea of everything we want our robot to look like even before we actually build it. And then once you actually start building it, you want to use good, sustainable, reliable parts that will be able to withstand the game, as sometimes the game can require a lot of force on your robot, and if you have a string that keeps snapping or something that keeps breaking, you're not going to do too well if your mechanisms break. Afterwards, you're going to want to start testing and iterating on these designs, and nothing will perfectly translate from anything to anywhere. And even if you think you have your final build, you will want a lot more time to test your mechanisms and then iterate them into the future. As even if you think, oh, this is the best our robot will get, that is never the case. Your robot will always be growing and improving throughout the season, and there will always be some issues in your prototype that may require small redesigns, which will just need a few kinks to be worked out. But other times you're going to have to do a lot of changes to your robot if you want it to perform well. Sometimes there'll be some issue that just causes your entire robot to malfunction that you can't really fix without making a lot of major changes. So sometimes you will have to make some pretty significant redesigns in your robot. So the more time you give yourself, the better, as if you have more time to redesign your robot, it'll give you more time to retest and reiterate before a competition, so that you're as ready as you can be no matter what happens. And between all competitions, just try and continue iterating on your robot and improve everything, but always keep an eye on how much time you have and how much you'll be meeting, as you don't want to make too big of a redesign change in between two competitions with a very small time window.
All right, next we're going to be going over the drivetrains. We have grouped these together to help create similarities. So a few things you should be considering while planning your drivetrain is speed, how fast the robot's going to move from one side of the field to the other, how much power, how much can it actually push. That's kind of depends on the season, but it should be still a little bit important for your process. Maneuverability, which means how easily can you navigate throughout the field. Traction is how much you might be able to get pushed around in the field, and you don't really want that most of the time. So you want to keep a pretty good high coefficient of friction between your wheels and the field. The terrain, sometimes actually most of the time there's objects you have to climb over or around, and that might affect how your drivetrain moves. And omnidirectional is kind of depends on how you want to move your drivetrain around the field. So there's the 6 different types of 7 different types of drivetrains that we're going to go over is the 4-wheel. We'll go over these more in depth in a few moments. 6-wheel mechanism, X drive, H drive, treads, and swerve drive.
Okay, so the 4 most simplest drive trains are 4-wheel, 6-wheel, and treads. 4-wheel and also 6-wheel, you can kind of use different wheels like traction and omni wheels. But in general, traction wheels are going to give you more traction, and then omni wheels are going to give you better maneuverability and be easier to turn. But they can also be easily pushed. And then you can combine the two, which can make it pretty good maneuverability, not as good as with 4 wheels, but you're not going to be pushed as much. And then treads, they have pretty good traction and can handle more difficult terrain, but they are not very maneuverable, and the treads can break. So you're going to want to make sure to buy high quality ones that are less likely to break. The Mechanism, Swerve, and X drive wheel drivetrains are more complex, but they can give you a better outcome. Mechanism and X drive can strafe, which makes them more maneuverable. Mechanism only works on flat fields without any custom design work, and they can be kind of complex to program. Whereas X drive, they can take up more space and be harder to place the motors, and they're also going to be complex to program. And then Swerve is very maneuverable and has really good traction, but it's a lot more complex, and it can also take up a lot of space and motors and servos.
All right, so we have our first question break right now. I forgot to mention this earlier. We have 7 question breaks, this being one of them. And if you have a question, you can either ask during this time, or you can either pop it into the chat too. So now, if you have any questions over the drivetrains or other content we have been over to, this is a good time to ask. All right, so like I said, if you have a question or you can't think of one right now, there will be other question breaks. So we'll move on from there. All right, so now we're going to go over drive methods. So there's a few different ways to actually achieve how to get your motor to your wheel. And there a few different ways is the direct drive, which is attaching your motor onto the wheel, chain drive, which is having a chain belt drive, and gear drive. All right, so the first thing you have to know about how to do driving methods is gear ratios. So basically how gear ratios work is that if you want to have gear ratio, there's going to be either a gear sprocket on the motor, and there will be another one on your wheel shaft. And then depending on how many times each gear spins towards another one is going to depend on how fast or how much torque your wheel will have. So torque and speed are inverses in this case scenario. And what that means is that the more speed you have, the less torque you have. And the more torque you have, the less speed you have. So if you want to lift something really heavy, it's really good to have torque. But if you just want to move something really fast, you want speed. So a speed gear ratio modded for speed would be really spinning really fast. However, it would take very little force to stop the actual wheel from spinning. And opposite for torque, it will spin really slowly, and it will take a lot of force to stop it, which is why it would be better for lifting heavy objects. So how to determine if you have a gear ratio for speed or torque is depending on how many the diameters of your individual sprockets or gears. So as you can see here, that the driving gear in the red will spin once for one revolution, it will spin. This blue one will spin 2 times, hence the 1 to 2 gear ratio. So what this means is that this is currently a gear ratio modded for torque, and this will spin twice for every once, meaning that it'll be very slow. All right, so now we're going to go over the 4 different types. So the first type is the chain drive, which is quite similar to the belt drive as well. So the thing you want to consider is that there's lots of flexibility with these two, and you can pretty much put your motors wherever you want to. And there's also variable gear ratios, which means that you can pretty much pick how fast you want your gear ratio to change. So us as a team, we strive for around a 300 to 400 gear ratio on our wheels, so we can move as fast as possible, but still having enough torque to push other robots around if needed. So each of these do have an adjustable length. The chains more so than the belt, because you can just add a few chains to the belt to the chain drive. However, with the belt, you would have to order an individual new belt for every time you want to switch where the motors are. So chain's really good for if you need something really fast, because it's really quick to put on and off in case if you need to add more or less links. However, you will need to tension your chain if it's not perfectly tensioned, which in most cases it's not, unless you catted it or designed it in a way that to make sure that it doesn't. And then chain will stretch over time because of this tension, and your chain can also snap in certain spaces too. With a belt drive, it can be really expensive to buy individual belts, and however, there's even more flexibility than the chain drive with belt drive, because you can have the option to print your pulleys and even possibly print your belts with TPU filament if you have that access to that technology. It's a little rare, but if you do, it's definitely worth it to try to do that. And with belt drives, it does require tension as well, and these can also often slip more prone to the chain, and like I said before, is a little bit more expensive. Or you can go with the direct drive, which is very simple, and it's very hard to mess up, hence the fewer points of failure, because it's attached directly to the motor. However, there is no flexibility with motor positioning, which means that you're kind of stuck with your motors being wherever you put the wheels. And there's so much speed going on between the direct drive that it can wear down the gearbox often. This is not too common, but over a few years, you could, or maybe even just 1 year, you can definitely see that happening. And it can definitely malfunction the gear ratio over time too. And finally, there's also the gear drive. So this is kind of similar in a way of the belt and chain drive. However, your 2 axes will spin in different directions, as well as there is also a semi-flexible motor positioning. However, this does depend on how many gears you wanted to sacrifice your space to put in a line to get there. And you can have this is probably one of the best ways to get a big change in gear ratios. However, these can slip and grind, which you want to try to use as much metal gears as possible, and from that you can experience malfunctions. However, there are opportunities to get your wheels at a 90-degree angle from your motors through bevel gears. This year, our team used these drive pods to have individual motors perpendicular to the wheels, so that we can store our motors in spaces we're not using.
All right, so tips and tricks. This is stuff we have learned through our experience, what we have. First of all, it's a really good idea to take advantage of D-shapes and hex shafts. Using these shafts will ensure that anything that attaches to it, like a shaft collar, for example, will be way more sturdy and reliable to use in comparison to like a normal round shaft. Because like these don't have enough grip on it, but a hex or D shaft has like a flat spot, which has a nice grip. Using consistent structures like channels makes it way easier to attach parts together. There are many similarities. Attaching parts together becomes way easier when you have a lot of the same pieces and becomes a lot more simple in design. And before you make a complicated assembly, definitely CAD and prototype. That is very important. CADing and prototyping will help you a lot. This helps you get an idea of what the robot will look like and how it's going to function and like how you want it to be built. And then you should always plan your drivetrain to accommodate mechanisms on the robot, which makes it way easier to attach any new mechanism later on or anything else that you're planning to add. All right. Any questions so far with anything?
So we do have one question in the chat. From John, are mechanism wheels 4, 8, or omnidirectional? Maybe you guys can talk a little more about mechanism wheels and how we've used them.
Yeah, so mechanism wheels are technically 4 wheels, but there are different, there are more wheels on each individual wheel. So the way that these mechanism wheels work is that so it can go forward and backwards like any other drivetrain, and it can turn left and right. However, there is an option if you spin your motors correctly to go straight left and right. So I don't remember exactly how you spin your motors, but on the left side, you want to spin your motors away from each other. And then on your right side, you want to spin your motors towards each other, and that will create a shift to the right, I believe, with your mechanism wheels.
Any other questions we have so far?
No others in the chat. That was a great question. So why don't you guys keep going?
All right, so now we're going to go over mechanisms. So the first thing you have to think about is there are three main steps of how you score points most of the time in matches. So the first thing is you have to obtain what element you are scoring, whether that's we'll go over more elements you can, there's in FTC later, but you would want to pick up your element, and usually there's you have to get your element from the ground to usually the top, or vice versa sometimes, and you have to get away from the intake position to the deposit position with a transfer element, which is we'll go over to later. And finally, there's a way to you have to score the element in any way possible of how FTC Game Manual 2 has described to score that element. All right, so first we're going to go over obtaining an element and considerations. So the first thing you have to consider is how reliable is your mechanism going to be. If you can pick it up really reliable once, however, you can't pick it up at all, you're kind of not too useful in the match, because there's usually many elements that you need to pick up per team, and if you can only pick up one, then you're not in a good spot. Minimal lineup is great because you want to cycle as fast as possible, and spending 5 to 6 seconds on picking up the element can really hurt your cycle time and possibly you picking alliances, or you maybe not getting picked. And it needs to be really fast, again, with that cycling speed. It needs to be versatile. It should be able to grab in almost any way, and it should be flexible. In case if something is knocked over, it should still be able to pick up then. And it should be dependent on what the shape of the element is. There are some really good mechanisms to pick up with. However, it's not always practical for every type of game element. And a few of those before we so we're going to go over what type of elements there are. So like what can you be scoring with, different types of grabbers, how you pick up cubes, maybe with like a claw, overhead spinning, dual side spinning, and passive, and we'll go over this now.
in every season, there's going to be one or two different element types, and the common ones in the past have been the cube and the sphere, which have been used many times in the past as a element where they need to be taken or moved or raised or put in a new area to score. But there's also been plenty of other unorthodox element types, such as cones, circles, uh, Lego brick looking things, or anything else that there could be. And so we'll be using and there's also the team element, which is used in some years, but it's not all used in every year. But you with that, you'll be creating your own element that will be used to score in some way or another. So, and there's many different ways to grab these, but these are some of the main ones that have been used in the past. So grippers or claws are used very commonly in this game, and we have used them in the past, and including last season. And claws are used a lot of the time just because of their versatility, as they can be used for many different kinds of element shapes and can be used in many different ways. So that just makes them a good choice in many different games and have been used in the past a lot by very good teams. But they are very limited in the range of motion, just being a claw, so they can't do too much if an object is large or has some certain way. So if you want to use them, you'll have to be very precise in your lineup of acquiring things, as since it's only a claw, you will have to line up your robot with whatever element you're trying to grab, or else you're not going to be able to pick it up. And that makes it a very time consuming process, which can hurt you a lot if you're not being precise, because then you're going to lose a lot of time on cycles, and getting cycles is how you score points, and it can hurt you if you don't use it correctly. Then overhead spinning is another very commonly used way to pick up elements, and so it's very fast, as it's just constantly running during a match, so you'll always be able to just go towards something and grab it, which is really useful with its lineup, as it's usually a very large mechanism, so you can just easily just go have your drivers drive over to something and that will automatically pick it up. And it is also has been proven in the past to be very reliable for the cubes and sphere elements, but it does take up a large amount of space, which can cause you to not have room for other mechanisms or other things on your robot, which could complicate things. And you need to do a lot of material testing to see what works best for every element in every game, as if you don't use the correct materials, it's not going to be collecting elements very efficiently. And another one of the really big intakes is the dual side spinning intake, which is just uses like either sets of wheels or other mechanisms to bring things into the robot. And it's very useful for cubes and all the other unorthodox shapes, as all it does is just spins and brings things into the robot. And it's very fast, as it's just a constant spin, so it will always move things really quickly as long as you have enough RPM. And it's usually very reliable, as it is used in a very cut and dry way, which allows you to easily grab objects pretty consistently over and over. But it does require some lineup, maybe not as much as a claw, but you will need to at least get in the correct direction and be at least sort of lined up to be able to pick things up correctly. And it is not very versatile, as depending on the element, it won't be able to pick things up very well, or it may just drop things in the process of trying to grab them. Now, if anyone else has any more questions, we are open to answering them.
We didn't get any additional questions in the chat, but if you have a question and want to unmute yourself and ask, this would be a good time to do that too. Excellent. Why don't you guys keep going?
All right, so next we're going to be talking about transferring elements, which can be defined as moving from the position that you have obtained your element to the scoring position to score your element. This sometimes can just be a lift, and this is also can sometimes be separated into like a transfer and a lift. So some things that you'll want to consider while you're making a lift. Stability. Stability is an important part because lifting, to the very definition of lift, you're going to be going high up and it's going to throw off your balance. So you want to make sure your mechanism is extremely stable. Height, again, that's going to play into stability. Almost everything on this list is going to play into stability of your lift, because the higher you go, the more unstable your robot's going to be. You're going to put yourself at risk of tipping, which is something that you obviously do not want to happen. So you want to find the perfect height. You'll be wanting to look at speed because you obviously want fast cycle times for your mechanism, but you also want to find that balance of not going up and down too fast to destabilize yourself. The weight of the end effector, so this can be like a claw, this can be some other like scoring mechanism that just weight at the top can often throw the balance of the robot off and put yourself at risk of tipping. So you definitely want to pay attention to how much that's weighing and how much that's totaling into the full robot weight. You want to look at a combination of different lifts. This could be something like a pair of slides and a chain bar at the end. This can either make or break your robot. If it's done well, it will be very effective in how it improves cycle times and positioning for scoring, but it can also, if it's done improperly, it will often slow your robot down and make it extremely hard to line up your robot with, like, for example, like from last year's game, a pull. So you definitely want to pay attention to what combination of lift you're choosing, if you're choosing to do that and doing it effectively. And then lastly, you'll want to consider space requirements. Obviously, when your robot is in its resting state, it needs to be fit within an 18 by 18 by 18 cube. But once the game is started, it can expand past that. So you'll obviously want to make sure your lift mechanism and any other part of your robot will stay within those size constraints, but you can also consider expanding it afterwards. And we'll be covering a single bar, a chain bar, a 4-bar linkage, and linear slides today.
All right, so one of the first things we want to discuss about lifts is the chain bar. This can be really simple, and it does maintain the orientation of the element, which means that the pickup position is going to be the same exact spot where you drop it off. However, this can not have a lot of leverage towards it, and there is range areas that it cannot reach, and there's limited range as well. So this can be complex a lot more into the double reverse chain bar. We have experimented with this in the past, and yeah, it's effective. However, it's a lot more complex than the chain bar. Then we have the 4-bar linkage is really similar to the chain bar in which way that it does maintain the element, the orientation of the element, which same exact thing. You pick it up from where you deposit. And however, it can be complex, and it has a really limited max height. You can see in the bottom 2 pictures in the middle is the pickup and the drop off is pretty much in the same range. So however, you can add as many different bars as you want, such as the 6-bar, you can 8-bar, so on and so on. However, this the more you add will take up space and harder to fit in the 18 by 18. And you can also use the double reverse 4-bar to maximize your space if you're using a 4-bar linkage. What this means that the space in which it's attached to the drivetrain is going to be the same exact area where it's going to be picked up. And finally, we have the linear slides, which is probably the most common method to move the element from pickup to deposit. So some pros is that it can have pretty much infinite range if possible, as long as you can fit it within 18 inches. Like I said before, it's extremely common, so that means that there can be a lot of help on the forums and different YouTube pages. And I'm going to say a lot of teams have their own advice on how they successfully make their linear slides. This can be semi-complex depending on the method. Cascade stringing is one of the most used methods. This can be really complex. We can see it in the right-hand corner, the right-hand picture of the two pictures of the linear slides. It can be really confusing to string and get a nice consistent stringing path as well, because there can be some, the strings can rub up against each other. And this only has a one vector of extension. However, you can combat this with the tilting of slides, on which that you can get the two vectors of up and to the wherever way you're going. And then there's a few different methods of stringing: cascade and continuous. So it kind of depends on how you're going to go with it. With cascade, you need a lot more torque on your motor, and continuous, you need a lot more speed. So it just kind of depends on how many motors you have. In our experience, cascade needs a little bit less, and it's a little bit more power friendly compared to the continuous, which might be a little bit better if you need to handle so much load. And then there are a few different ways to make these motions move through string, belts and chain, and lead screws. So stringing is probably the most common that you see in FTC, because it's probably the most space effective compared to the belts and chains. However, it can be hard to make sure that your string does not snap. So we found string on Amazon. It's called UHMW string. So this has around 600 pounds weight limit, which is really good for our team. And I think we've only had our string snapped once or twice, compared to maybe a 100 to 200 weight limit, which it does snap quite often, even though we may not be lifting 200 pounds. Finally, there's the lead screw. You can see a picture of a kit from GoBuilda in the bottom right-hand corner. This can be good depending on how the season is. However, it can be slow because you are using a lead screw, which is a really high gear ratio, meaning it's slow. But it can be useful based on the different types of things you might have to do. And we're going to go over how you're scoring the element next. This is how you're most of the time you're going to get the points after picking up, then moving it towards the scoring position. So we're going to go over scoring zone types and tips and tricks. All right, so there's a few different types of ways you score in the FTC. A few examples are launching, dropping, pushing, bouncing, and lifting. But there are other ways, such as you can park in autonomous most of the time. And but yeah, I'd say some of the more common ways is launching. Usually there's a launch game every about 3 to 4 years. Dropping is not, often pretty common too, because you have to find a way to drop your element into the goal most of the time. Pushing is not too common now, because usually the game designers are more in favor of dropping and launching. But balancing is definitely something to be considering, that it's possible. 2 years ago in Freddy Frenzy, we had the choice of balancing these goals, and same thing the year before with wobble goals and ultimate goal. And lifting can happen, it's not too common as well. So you can see here that we have few different examples. I believe Rover Ruckus here, that was dropping. I think most of these are dropping. Maybe this one might be launching, but I'm not too sure. But yeah.
So here are some tips and tricks for scoring elements. These are things that we've learned throughout the years. So keep it simple. Obviously, this is a philosophy you've probably heard of before: keep it simple, stupid. And that especially applies to scoring elements. By increasing the complexity of the mechanism that you're going to be scoring with, or increasing the complexity of like your scoring process, you're just going to be adding more opportunities for failure, essentially. And you definitely don't want that while you're scoring. So obviously keep it simple and reliable. And that brings us to our next point: focus on reliability. Consistent cycles, I cannot emphasize this enough, but consistent cycling times and speeds are going to be your best friend. It's going to create consistency, which is obviously going to help you score more points, but it's also going to look better for other teams when they're possibly choosing you for an alliance. So they're also just like looking for judges, looking at matches to consider you for certain awards, etc. Is it easy for the drivers? So you have your robot, right? But your robot robot is powerful, but it's only limited by the capability of the drivers. So along with a lot of driver practice, you're also going to want to maximize like the easiness of scoring for your drivers. Whatever is you need to accommodate the drivers as much as possible so that it's easier for them to score points and be consistent when they're doing it. Researching past games is a really good one because it's going to allow you. A lot of times FTC like will just incorporate elements of past games into the game that might be like this next year. So you can look at what people have done in the past to gain inspiration and just in general like inspiration design ideas from these past games and help them create a more efficient score mechanism. And also you can look at other teams, look at what other teams have done in the past, look what they're doing. Like when the game first releases like Robot in 24 Hours videos, or even later in the season, you can also look at like open source CAD libraries to see what other teams are doing for their scoring mechanisms and just robots in general. And any questions? If you want to speak up and unmute, you can ask a question, or you can also type it in the chat.
See, it's clear you guys are just hitting everybody's questions as you go through. But yeah, interaction is like good if you guys are going through this and have something that these kids have a ton of experience and have seen a lot of different things too that they might be able to help you with even specific items.
Nothing is a stupid question. Any question is fine.
Chances are if you have a question, someone else has the same question, so you're really helping everybody.
All right, we have one from Alex. What is the benefit or difference in one server versus two for a swerve drive?
All right, so in a swerve drive, you do need 4 motors, maybe possible or combinate so you need 4 motors for sure to drive the wheels. However, you also need an additional either 4 motors or 4 servos. This can be done with either of those ways. Servos would probably be the most beneficial, but the way swerve drivetrains do work is that all the wheels, so you have 4 motors driving the wheels through bevel gears most likely, and then you also have 4 servos changing the direction of where the wheels are going for the maximum acceleration as possible. So it is possible to get a swerve drivetrain with 2 servos, I believe, if you have 4 dead wheel omni wheels in the end, and then 1 swerve pod in the center. That's probably going to be the most typical FTC mechanism on a swerve drivetrain right now. However, depending on the weight of your mechanisms that goes on top, it may not be very practical because you do have 1 or 2 modules of the swerve drivetrain carrying your entire robot, which may not be ideal. So I would recommend, if you do choose to do a swerve drivetrain, I would do 4 motors with 4 servos. And if you have a problem with servos, Axon Servos is a great resource to do. They pretty much came up with a whole entire website dedicated to like 5 different types of servos, and it was pretty much created for FTC purposes.
All right, great. Go ahead and carry on.
So once you've built your robot with all of the tips and tricks we just went over, you're going to have to drive it. And for that, you're going to need some specific hardware. So on the robot, you're going to see your control hub and your expansion hub nowadays. But previously, you would have 2 expansion hubs, and then you would have a phone separately, which were used from 2016 to 2019. So not too long ago. Those would interface with your motors and sensors, carry your program from the phone to the hubs, which would then carry that down to all of your hardware, your motors, sensors, servos, etc. The connection between the phone and the hub, though, was a failure point. So it's a place where things could go wrong, things could come disconnected. You know, it's just, you want as little transferring between things as possible because it's less places where things can get lost. It would also require you to charge the phones, which is something that either you may not have time for or something may die unexpectedly, and then you can't drive your robot. So in 2020, first introduced the control hub, which integrates the phone into an expansion hub, essentially. And you have all of the motor ports and servo ports and all of the ports that you would have on an expansion hub, plus the control hub is able to store your program, and that way you have fewer devices you need to manage and fewer points of failure. Thank you, Malia. Android phones will be illegal starting from the 2024-25 season. So if you're still using phones, stop it. So this is what the expansion hub of the control hub look like. As you can see, they're very similar. They have all of the same ports. The control hub has that orange stripe to identify it, and it has a little bit more functionality than the expansion hub. In order to actually drive the robot, you're going to use your driver station. So in order to control your robot, you would use the driver station app on an FTC legal phone, which would be found in Game Manual 1. If you have not read Game Manual 1, highly recommend, lots of good information in there. The phone would have 1 to 2 controllers plugged into it, depending on how many people you have driving, and those controllers would be used to operate various functions on the robot. So you would hit a button or move a joystick, and that would correspond to a function and move your robot around. You cannot modify or program the drive station software. You have to work with what FIRST gives you. In 2021, the phone was replaced with a driver hub, which does not require a phone and provides a little bit more security against disconnects, both physically and through Wi-Fi. Physically, because rather than using an adapter plugged into a phone, you would plug the controllers directly into the drive hub, so they're a little bit more secure. There's less chance of it getting pulled out accidentally. And the drive hub uses a 5 gigahertz connection rather than 2.4 that the phones were capable of. So there's less chance of interference on the Wi-Fi channels, and your connection is a little bit more secure wirelessly to the robots. In order to connect your drive hub to your control hub on your robot, you can pair it through a Wi-Fi network. So you would use Wi-Fi direct pairing to connect the driver station app on your drive hub or your phone, but probably your drive hub to the robot. You will need to be connected to a Wi-Fi network, which the control hub creates and the driver station connects to. Differing channels may have differing amounts of other devices, but because there is a specific network coming from your control hub, shouldn't interfere with your connection to your robot. So we have a series of images here. The little red boxes show you what to hit press. So first you're going to hit those 3 red dots. And then you're going to hit the settings option that pops up. And then go to pair with robot controller. And then once you're in there, you should hit the Wi-Fi settings button. And from there, you select your control hub's Wi-Fi network. Ours is called 10464 test in this image here. Yours is going to be named something different. You can change the name. That's a bit of a process, but just make sure you know what it's called. In order to configure your robot, we're going to go over some of the basics. It's generally pretty straightforward. There is some documentation from Rev, which manufactures all of the hubs, and there is a FIRST wiki. We have links to all of these things that we can give you at some point, and feel free to contact us directly if you need any more help. So we're going to go ahead and play this video. If you want to full screen that. So you're going to go up to the 3 dots in the corner of the screen, that top right corner there. So yeah, and then you're going to hit configure robot, and you're going to hit new up in the top left corner of the screen. And then you can hit the scan button and nothing shows up, but you should have a control hub portal, assuming you're using a control hub. And then you can go into either the expansion hub or the control hub once you get into the portal. And from there, you'll see a lot of menus and stuff of different types of devices. We went into motors here. You're going to choose your type of hardware device. In our case, that is a Matrix 12V motor. And then you're going to type in what the name is. We just called this one motor 1 for simplicity purposes. It is a motor. So I recommend naming your motors or servos or whatever devices you have something similar to their actual purpose. That way you know what they are when they're looking at them. And so you get back to this menu, you're going to hit done a bunch of times, then you're going to hit save, and then you can enter a name for your robot configuration. We just called this one config, again, because it's for display purposes. So it's just kind of describing what it is. And then once you are done entering the name, you're going to hit that little blue arrow. No, you're not, because that actually just creates a separate line. You're going to hit the done button, and then you can hit OK. And it will save your configuration, and then you can activate that whenever you need it. You can have as many configurations as you want, but you probably don't need that many. So that is how to configure your robot. In order to avoid disconnects while you're playing, because you don't want to have a disconnect while your robot's on the field, that would prevent you from scoring points, and we all like to score points. So make sure that all of your physical wire connections are strain relieved. Make sure you have a little bit of slack in those wires so they don't come undone. We've definitely had wires pull out of connections during the match. It is not a good thing. You will lose control of that piece of your hardware. Not fun for anybody. Make sure that your batteries are fully charged. If your battery dies during a match, you will not be able to replace it. Your robot will sit wherever it was when the battery died, and you will just not be able to play out the rest of that match. So make sure you have a battery charger in your pits during competition so that you can charge your batteries whenever they're not being used, and swap out a fresh battery for every competition match. That way you can make sure that nothing is dying prematurely. Make sure your Wi-Fi spectrum isn't too saturated. Which is something that, you know, a lot of the times will be taken care of for you at competitions. Just make sure you don't have any hotspots. We typically, our drive team leaves our phones with our cart a little ways away from the fields. Turn your phones into airplane mode, make sure there's no connections that could interfere. The Rev grounding strap, anti-static spray, that's mostly for your home field. Make sure that that is anti-staticed up at competitions. If there is a repeated issue with static, the FTAs will take care of it, and they will make sure that there is no future problem. And then make sure that all of your wires are intact, because if you have a frayed wire, it could lead to a short or potentially an electrical fire. And neither of those things are things that you want to happen on the competition field. Have any questions about any of that? Why will the Android phone be illegal? So I'm not a first official, so I can't say for sure, but it's probably just in order to move forward, or they have some features that are, it's most likely to just try and transition toward the driver hub, which has most of the same functions as an Android phone, it's an Android device. So they're trying to make sure that everyone is on the same technological level.
Yeah, there is some where first tries to keep the technology that they're supporting to a rational minimum. So they occasionally make decisions such as this. And they may also have noticed potentially, I've seen this in the past as a mentor, where they've seen trends with, you know, as Jamie was talking about with Wi-Fi crosstalks and those kinds of things causing disconnects and other problems. It's possible that Android phones were having more of a problem than others. But so that's something that they're doing. There's another question from Jason that's called, do you have a preference for what brand of motors you use?
So we usually use GoBuilder motors mostly for the most part. However, there are one type of motors that we believe are the strongest compared to GoBuilder, and that's AndyMark. They're called Nev Rust motors, I think, something along those lines. Yeah. These are a little bit more powerful, but we usually only typically use those for our drivetrain because they only come in 2 different speeds, and GoBuilder has like 10+ speeds, which is good for flexibility issues. We tend to stay away from Revs motors because those aren't as powerful. But if you have those, you use what motors you have, and then you can buy more that are more powerful.
All right, why don't you guys keep going? And for those of you on the call, keep using the chat for questions.
Understanding hardware.
You can go, Alex. I'll answer in the chat.
Okay. Do you control the slideshow? Okay, so what do we control? In FTC, we can control motors. We can have a max of 8, 4 on the control hub and 4 on the expansion hub. They're continuous rotation, meaning they constantly spin. They're the most powerful thing in FTC from torque and speed. They're good for mechanisms and drivetrains, and we control it by giving power. Servos have a max of 12, 6 on the control hub, 6 on the expansion hub. They have 2 modes, continuous rotation, which means it will constantly spin, and servo mode, which means it will move to a position and try to hold that position. They're good for moving light things or releasing things such as a claw, and we control it by giving it a power or sending it a signal. What are inputs? One of our inputs is the gamepad, which lets us take inputs from the drivers directly. A lot of them are true and false inputs, just if it's clicked or not. One of them is the joystick, which allows us to see the X and Y axis and where it is there. We usually use that for drivetrains. Sensors allow us to get data from the robot. One of the biggest ones being the camera, which allows us to see what the robot's seeing, and then we can use the image processing or TensorFlow to see what the robot sees. Another one is the distance sensor, which allows us to see how far away something is. Another one is the color sensor, which lets us see what color something is, and the encoder. So this is a diagram of every input that we have on the gamepad. And then sensors, I already covered this a bit, but all sensors work a bit differently. So you have to understand what the most basics are, or you have to understand what the differences are between them and how to use them. There's a lot of documentation on all of them. And encoders, they're extremely useful. They allow us to see how many times something has rotated, which using math we can turn into degrees or turn into a position like in odometry, where we can see how far along we are on the field. And some motors have these built into them.
All right, so we have a question in the chat. Do you prefer Go Build frames and stuff to then? So we mostly use the Go Build quad blocks to mount most of the stuff. However, they also do sell these clamps that there's a loop around that you insert the motor into it. These can work fine. However, that if you don't tighten the clamp enough, it can tighten. It can rotate along with stuff. We typically use these for spools for our lifts, for our slides. However, usually if the opportunity does come, we do choose to use a quad block over the clamp.
Any more questions? Anything else?
All right, I believe this is our last section in our presentation today, and we're going to be going over wiring, how to wire your robot. All right, so this is the first main way you have to wire your robot to give power and signal to your expansion hub. So first off, we have to have our legal our legal battery. I think we use 12 point something volts. We buy these off of GoBuilda, which are also available on Rev, I think maybe, or some other vendor, might be AnyMark. And then we connected that through the power switch. You have to have one for your robot. That's very important. You will not pass inspection if you don't have a power switch. We get our power switch from Rev, which is one of the 2 legal ones. I believe you can't get one from. I don't know the name of the other one. All right, so then each control expansion hub have 2 power ports in the top left-hand corner. One of those on the control hub is going to be used for power, and the other one's going to be used to give power to the expansion hub. So if we can see on the far left, I believe that one's the female end. We use that to plug in the 12-volt battery, and then the male one is used to give power to the expansion hub. And this blue, white, and black wire is very important to give the signal to the expansion hub. Without this wire, you will have power to the expansion hub. However, you will not have the capability of running any servo motor or sensor from that wire, from the expansion hub. And now we have how to plug in a motor. So from the same exact setup from before, we would use that, and you can plug in 8 motors in total, 4 into the expansion hub and 4 in the control hub. So the way you do this is that you have your typical motor, and then it has 2 cables that red and black that move into the to the left ports in the control or expansion hub. All these are the same, and like Alex mentioned before, motors do have some motors do have encoders attached inside the motor, and that is used that will be plugged into the this black cap in the ArcoBuilder motor, and will also be in the bottom of other motors that are compatible with the encoders. And then it will go through this yellow, green, black, and red wire, and through this logic converter, and then it will then plug in right underneath where the motor is plugged into. All right, next we're going to go over servo plugged in. So this can be very simple, which is just plugging it into the as seen in the top left-hand corner, plug into the controller expansion hub. There are 14 ports. However, 2 of those on each expansion hub and control hub are 5-volt powers, which we stay away from as a team because it is bad for our servos. And I don't know, and then these just plug in, I believe black's on the left and right, and yeah, black's on the left and white's on the right. And there's a little schematic picture on there if you ever forget about that. And then there's also a servo power module as well. I believe these are you can buy these on Rev, but however, I do believe they're out of stock and maybe permanently canceled. However, if you can get your hands on one of these, this might really improve your robot. So basically what this does, it converts the servo power from, I believe, around 3.3 volts to the a full 6 volts of charge, which makes your servos have a lot more torque and speed as well. And this is just generally great for giving more power to your servos. Yeah, these are great if you can't get your hands on them. If not, the Axon servos are perfectly powerful enough too. Or you can also choose to use GoBuilda, and we bought these blue ones from Amazon. Yeah, and if you ever have any questions about wiring, there are schematics on Rev for all the wiring too. If you have any questions, those are sometimes can be very helpful. And we're going to be going over our how to plug in your camera, which is so there's 2 USB ports on the top of the control hub only. Expansion hub does not have any of these. And from there you will get to see the we use our camera for mostly randomization and autonomous, but you can use it for other stuff too. I've seen teams that use it to track where they are on the field. And there's also an HDMI port on the top of the control hub. This is used so you could see what your camera is looking at on the field. So what you can do with this HDMI cable is you can plug it into some kind of either monitor or software on your computer, so you can see what you're looking at from your robot view. I do believe that that the driver station does have this capability too. However, it's just sometimes it's really good to have the full wide view. All right, and now we have a question break. Yeah. So we have a question. What's the logic converted for? So I don't know exactly what it's used for, but I do know that you have to have one. So basically the gauge of the wire that goes from the motor to the hubs are different gauges. So I think that's part of the reason why. And generally, I do think it's just to translate how to get from the rotation to the encoder port. I'm sure, yeah, I'm sure someone has a better answer on there on the FTC forums, or maybe possibly on Rev's website, but that's as much as I can help you. Sorry about that. So on Rev, you would have to buy these individually. I believe they are out of stock right now. However, they do sell these on the Rev website, and they do not come with the motors. However, there are packages where you can buy these. Yeah.